Good morning, Math 10s. We're moving on to lesson 3 in measurement, which is on volume. And I'll say that most students, they tend to find volume much easier than surface area. They find that there's a lot less work to do with volume. Remember that when I said surface area, I always tell students to imagine that they're painting the outside of an object. With volume, what I tell students to envision is that you are filling up a hollow object with, let's say, water or sand, and it's going to be how much water will your object contain. Okay, so that's what volume is. Volume is a measure of the amount of 3D space that an object takes up, and you always imagine that the object is hollow. Okay, volume is measured in cubic units. So I'll show you the reason why it's measured in cubic units, and then you just have to remember for surface area, you square your units, and for volume, you cube it. So this is a rectangular prism, and let's say that the formula for a rectangular prism, if I go to the formula sheet, it's right down here. So here was surface area, which we used in lesson 2, and now we're going to use volume, these formulas here, for lesson 3. So volume of a rectangular prism is length times width times height. So let's write that down. And actually, I'll use this one. So the length, 1, 2, 3, 4, 5, 6 units. And the width is 3 units. And the height is 6 units as well. So if I was to calculate this, it would be volume is equal to, and let's just say it was centimeters for now, because it will help you visualize this a bit more. So volume is equal to the length, which is 6 centimeters, times the width, which is 3 centimeters, times the height, which is 6 centimeters. So if I go to my calculator and type in 6 times 3 times 6, I would get a total of 108. And then remember, a centimeter times a centimeter times a centimeter is a centimeter cubed. Okay, so that's why volume has cubic centimeters or cubic units. And remember that if units aren't given, so I just added the centimeters in here, you could always say more correctly for that example, it should be 108 units cubed. Okay. So going back up here, volume is measured in cubic units, and it'll often be something like centimeters cubed or meters cubed, inches cubed, it could be feet cubed, or if all else fails and they don't list their units, please always write down units cubed. Okay? Okay, let's quickly find out the volume of this rectangular prism. Volume is equal to length times width times height. And I'm going to say that this is my length, this is my width, and this is my height. Remember that, like with surface area, you actually don't need your units until the very end. So 3 times 4 times 5. And if you punch that in your calculator, 3 times 4 times 5, you get 60. Then I'm going to go over and I'm going to say, okay, my units was centimeters, and I cube that. Let's do the cylinder. So go to your formula sheets and find where the cylinder is. So here's a cylinder. That's your surface area. That's painting the cylinder. Here's filling the cylinder up with water. So pi r squared h. So the formula for the volume of a cylinder is pi r squared h. Okay. Example number 2. What is the volume of the following cylinder to the nearest hundredth? Remember that a hundredth, that's 2 decimals. Sometimes students will say to me, how do you remember that like a hundredth is 2 decimals? So I always say, well, if you write the number 100, how many zeros does it have? And it has 2 zeros, so that would be 2 decimals. If I asked you to give an answer to the nearest tenth, let's say, write the number 10. The number 10 has 1 zero, so that would be to 1 decimal place. So that will help you remember. Okay, volume of a cylinder, always state your formula, pi r squared times height. That is equal to pi, my radius is 6, squared, and the height is 9. If you were to plug that on your calculator, the volume of this cylinder is 1,017.88 feet cubed. So to the nearest hundredth, double check that for me, but to the nearest hundredth would be 2 decimals, and this is the answer that I get. At the end, you always want to tell me what shape it was or what the object was. So volume of a cylinder is equal to, and then your final answer. Okay? The formula for the volume of the pyramid is given on your formula sheet. So let's look at our pyramid. Here's our formula here, and I'm going to need to explain something from here because some of you might be saying, well, what is this big B? So let's write this down first of all, that the volume of a pyramid is 1/3 big B times H. So 1/3 times big B times H. You need to know what big B is, and big B is area of the base. Okay, so if you look at a pyramid here, a pyramid is sitting on either a square base or a rectangular base. And in order to get big B, you need the area of this base, which is just length times width, right? So it's 1/3, and remember that fractions, you always type in a bracket, times big B, so whatever this times this is, and then that times the height, which would be that number there, from the apex to the center of the base, okay? Okay, let's look at class example 3, see if we could figure this out. The volume of air in a right square pyramid is this. The length of one side of the square base is 27. So they tell me that it's a square base, so it's 27 by 27. Okay, so if I had to calculate the area of that base, what is big B? It's just going to be 27 times 27. Now we always start by writing our formula down, right? So they tell me that this is a right square pyramid, and the formula for volume of a pyramid is equal to 1/3 big B times H. Now we have to plug in, they give me actually the volume of a pyramid. It says the volume of air in the pyramid is this number here. So if I said, okay, well, where does this 10,449 go? Does it go for B? Does it go for H? Does it go for volume? Where would you put it? I'm hoping that you guys would see that it would go here. That's the volume. They actually calculated the volume for you. So 10,449 is equal to 1/3 times big B times H. Okay? Then it says, it tells us the sides of the square base. Okay, so I'm able to actually calculate what big B is. And what the question is asking is what is the vertical height? So they actually want us to manipulate this to get what height is. So let's actually put in what big B is because we're going to know what that is. So I've got 10,449 is equal to 1/3 big B, which is the area of the base, is 27 times 27. So 27 times 27, and then this is all times the height. So 10,449 is equal to 1/3. Let's figure out what 27 times 27 is. And we get 729 times the height. Let's continue on. So we've got 10,449 is equal to, it's 1/3 times this times height, right? So let's figure out what 1/3 times 729 is. So open bracket, 1/3 times 729. Okay, that's 243 times the height. And if I said, okay, well, how would you guys get height? You need to isolate h. H is being multiplied by 243. The opposite of multiply is divide. So divide both sides by 243. And then I'm left with the height is equal to 10,449 divided by 243. And I get 43 as my answer. My units are in meters. So the height is 43 meters. There is a check that you could do. What would your check be? Your check would be writing the volume of the pyramid. So let's write check. Volume of a pyramid is equal to 1/3 big B times height. Let's use we know what big B is, 27 and 27, and let's check this 43. Okay, so I'm only going to type in the right-hand side. So 1/3 big B is the area of the base, 27 times 27, and the height that I got was 43. And I'm going to type this into my calculator. What would you be looking for? What answer do I hope spits out? And I hope that 10,449 spits out. And if it does, then I've done it correctly. So on my calculator, I'm going to type in that 1/3. I'm going to type in 27 times 27. And then I'm going to type in my height, which I calculated to be 43. And look at that, 10,449. So the volume is 10,449 meters cubed, and that was the volume that they gave me, right? So my check works out. Okay, let's go to a cone. So it's a nice basic um, formula. So if we go to our formula sheets, there's a 1/3 again, pi r squared h. So volume of a cone is equal to that 1/3 pi r squared times height. Determine the volume of this cone to the nearest cubic inch. Okay, so I always start with my formula, pi r squared times height. I'm going to need my radius. The diameter is 12. Therefore, radius is equal to 12 divided by 2, which is 6. And the height of this, remember, it's always going to be the height inside the cone, and the height is 18. So the volume of the cone is 1/3 in a bracket times pi. The radius is 6, square that, and the height is 18. So I want everybody to punch that in on their calculators. So 1/3 in a bracket, close that bracket, times pi, times 6 squared, times 18. Round it to the nearest cubic inch, so that means no decimals. Pause it, and then see if you get the same answer as me. Okay, if you got 679 inches cubed, you got the correct answer. The next shape is our last shape, and it's the hemisphere. So way easier than painting an object. So surface area was more complicated because remember with surface area, we had to paint this object, the sphere, we had to cut it in half, and then we had to add that circle, that blue circle. With volume, we don't have to do that. You figure out the volume of a hemisphere, and let's say you calculated, or sorry, you figure out the volume of a sphere. So let's say you calculated the volume was 100 drops of water. 100 drops of water fit into this baseball. Well, if I said, well, how many drops of water would fit into each hemisphere? You take 100, you divide it by 2, each hemisphere would be 50 drops of water, right? So volume is nice and easy for a hemisphere. So again, the formula is not on our formula sheets. We have to look at our formula sheets, and they have a sphere. So we need to use this 4/3 pi r cubed. So volume of a sphere is 4/3 pi r cubed. And then you figure out what an entire sphere would be. And to get a hemisphere, cut that guy in half. Okay? So volume of a sphere is equal to 4/3 pi r cubed. So if this was an entire basketball, how much water would go in this basketball? It would be 4/3 pi 8 cubed. So let's all punch this in together on our calculators. So calculators out, clear it, open bracket, 4 divided by 3, close that bracket. Second function pi, radius was 8, and we're going to cube it. So there's your little hat button, brings you to the exponent, cube it, and then I always like scrolling out. Okay, remember we never round until the very end. So 2144.6605. So 2144.6605. Now, that is an entire basketball filled with water. If I want half of a basketball, take that number and cut it in half. So the volume of a hemisphere is equal to that number divided by 2. And then I'm going to look at how they want it rounded. They want it rounded to the nearest tenth of a centimeter, which is 1 decimal. So 1072.3. I need to look at my units, centimeters. This is volume. I always cube it. And that would be your answer. Okay, that almost concludes the lesson on volume. If you guys were writing an exam in class, and I might actually think about something like this for your exam that you're going to write online, this would not really be, it is a composite object because it's more than one object. Let's do this question together. This would have been on your exam. What it says is a soccer ball is packaged in a cubed shaped box. Okay, so we're given a box, a rectangular prism, and I could easily find the volume of that box, right? So pretend that basketball wasn't in there, and I said, like, how much water would that box hold? You would say, well, the area, or sorry, the volume of a box is length times width times height, right? You could also calculate the volume of a ball. So we need the formula for the volume of a ball, which I'll give you in a second, or we'll look on our formula sheets. And what this question is saying is, what is the volume of the space left over in the box that's not occupied by the ball? So, like, how much air is left in all of these corners if you put that ball in there? And I hope that you would see that, let's just say the volume of the box was 100, right? So let's just say 100 droplets of water fit into this box. And let's say the volume of the ball was 80 droplets of water. Then if you put that ball in this box, the remaining space would be, if you subtract these two, and it would be 20. Okay, so that's how you would do this type of question if it was a volume question. So let's figure this out using the actual numbers. So the volume of a box is length times width times height. So the volume of the box would be 20 times 20 times 20. And 20 times 20 times 20 is 8,000 centimeters cubed. That's the volume of the box. The volume of a ball, so I got to look at my formula sheet. So a sphere, 4/3 pi r cubed. So volume of a sphere is equal to 4/3 in a bracket pi r cubed. The radius of this is 10. I'm going to cube it. So that guy I need to do on my calculator. Open bracket 4 divided by 3. Close that bracket. Pi. The radius was 8, and we're going to cube that. Okay, that's the volume of my basketball. The volume of my, remember it was 20 times 20 times 20. So there's my box. I'm going to subtract the volume of the basketball, and then I could round at the end. The volume of leftover space in this object. Now, what did I do wrong? Because I'm getting a different answer. I'm just going to pause this for a second so I can figure out what I did wrong. Okay, sorry about that, guys. I had to figure out what I did wrong. I don't know how many of you caught my mistake. My mistake was actually up here. The radius of the basketball I typed in is 8, but it wasn't 8, right? The radius was 10. So I need to fix that. So let's calculate the volume of the ball. I'll show you how you could fix it if you have this type of calculator. I'm going to select this. I'm going to go back in here, and I'm going to type in 10. Close that bracket. Okay, so the volume of the ball is 4/3 pi radius, which is 10 cubed. There is my basketball, the volume of the basketball. And so it's the box minus this. So let's try this one more time. 8,000 minus this guy. And I get 3,811. They want it rounded to the nearest, let's just round it to the nearest cubic centimeter, so no decimals. And the leftover space in the box would be 3,811. So volume of space is equal to 3,811 centimeters cubed. Okay. Just to go through the homework. So I want you to do lesson 5 or question 5, which is this one right here. Determine the volume of each hemisphere. So remember, use your formula for volume of a sphere, divide that number by 2, and you're done. Going to this page, calculate the volume of each right prism. So this should be nice and easy. Length times width times height. Your cylinder, I'll write for you. So let's write the formula for the cylinder. Pi r squared h. Pi r squared h. That diameter you're going to have to cut in half. So don't use 16, use 8 for the radius. Do number 8, both of these. So the right pyramid, remember the formula for the right pyramid was 1/3. Actually, just let me double check that. Pyramid, 1/3 area of base times height. So big B times H. Remember, big B is area of the base. So this base would be 3 times 3, and this base would be 6 times 7. And the last 2 questions for homework. The volume of each of these cones. If you look at the cone again, 1/3 pi r squared times h. So always in a bracket, pi radius squared. So that guy you're going to have to cut in half times the height. The height for this one is 11. Height for this one is 9. Okay, and that concludes lesson 3.